Hi. In this video, I'd like to go over the basic mathematical concepts we use in just intonation. So it's not really very advanced math that you need to get up and running and understanding just intonation and different musical temperaments and microtones. The way we get into our intervals and what they really are in terms of their musical ratios. Okay, so once again, first thing, of course, to understand is musical ratios. So I've got some links to the playlist below, and I've extensively done a couple, very long videos on the harmonic series where you could really learn about the ratios more in detail. But just to recap here, so musical ratios like 2 over 1, 3 over 2, 4 over 3, and the understanding of how 2 over 1 is literally the pitch generated from the second harmonic over the pitch generated from the first harmonic, and the distance between those two pitches is an octave, and their relationship is 2 to 1, okay? So complementary intervals. Okay, that's the next thing that's really important in my opinion. So basically, when we're talking about intervals and just an equal temperament, if you have, let's say in the key of C major, we go from C to D. So from C to D is a major second, we call that, right? Now from D to the higher C is some sort of seventh. Right, so in equal, when we're looking at our basic intervals and in equal temperament, we're using an 8-note system, right? C, D, E, F, G, A, B, C. 8 including the octave. And so 1 plus 8 equals 9. So whenever you want to figure out the opposite interval, you subtract what your interval is, what your your lower interval is from 9, and whatever the opposite of that is, that's your reciprocal or your complementary. So for instance, a major second, right? So we take 9 minus 2 is 7, minor 7, that would be our reciprocal, right? Major third, reciprocal would be minor 6, okay? So same thing happens with musical ratios. So if you have a ratio of 9 over 8, then its reciprocal would be 16 over 9. Okay? If you have a 5 over 4, reciprocal would be 8, or complementary interval would be 8 over 5. I use complementary kind of synonymously with that. I say complementary or I say reciprocal. Those are the same thing to me in my mind. Okay, so now we're going to have this idea of prime numbers. So as you recall from your, basic math multiplication back in middle school, a prime number is any number that's divisible by 1 and itself. Okay, so examples, of course, are 2, 3, 5, 7, 11, 13. And then where those come into play once we get into, these different tuning systems is limits. So a limit is the highest prime number that is used in the ratios to determine the tuning system or the temperament that you're using, or really the tuning system. So for instance, a 2-limit system would just be octaves, right? It would just be like different octaves of the fundamental. A 3-limit system could use the perfect fifth, 3 over 2, and multiplications of that. So 9 over 8, 27 over 16, 81 over 64. And then also 2 over 1 and 1 over 1, right? So we could have octaves and ratios built, or tones built on ratios from the 3 over 2, from the third harmonic. Okay. So primary intervals, now there's a little mathematical formula, but the way I think out of these primes, there's a formula I've written out here. But the way I think of them, it's the lowest ratio from that prime that you use. In other words, 2 over 1, that's the second. 3 over 2 is the third harmonic. 5 over 4 is the fifth harmonic. 7 over 4, seventh harmonic. 11 over 8, 11th harmonic. So it's really the first time we use that interval, that definitive interval of that harmonic ratio. That's what I consider to be the primary interval. Now, when we add ratios, we basically take two ratios and we multiply them together. That's how we add them. So in other words, if you have the 5 over 4, okay, of your 1, right? So if you have you've tuned something, you've got your fundamental, you've got a 5 over 4 interval or pitch above it, and you want to get, well, what's the perfect fifth of that? Well, I would times 5 over 4 times 3 over 8. 3 over 2, and we get 15 over 8. And then subtracting is the opposite, okay? So you take, well, I wouldn't say it's the opposite. What you do is you take that lower number and you flip it, and then you multiply. So, for instance, if we had 4 over 3 and 3 over 2, and we want to find what's the difference between those two ratios, we would take the 3 over 4 and flip it, and then multiply those two ratios together. So 3 over 4 times 3 over 2 is 9 over 8, okay? And then the last thing we want to talk about real quickly is a tuning lattice. That's a multi-dimensional diagram that represents a tuning system. So right here we've got the basic building blocks of a 5-limit tuning system. And if you look at this little triangle right here that I'm circling, we've got 1 over 1, 3 over 2, and 5 over 4. So moving up, it goes up 5 over 4, and moving across, it goes across 3 over 2. So then this would be 3 over 2 times 5 over 4, 15 over 8. 3 over 2 times 3 over 2, 9 over 4, and then we bring that up to the, to its range inside of an octave, so that's 9 over 8. Times that by 5 over 4, 45 over 32, times 3 over 2, 27 over 16, etc. Okay? So basically, I just wanted to give you an introduction to the building blocks of mathematics, basic math that we use with just intonation. And a lot of these are pretty standard understandings of this stuff, but I took this information primarily. I'm using David Doty's Just Intonation Primer as my primary source for this material, and I would highly recommend picking that book up. Okay, so please join me for some more videos on microtonal guitar.